Hi, in this video we are going to learn about chain rule for differentiation. So what is actually chain rule? So let's say we have composite function f and g. How can we actually differentiate this composite function? So the answer to this is actually chain rule. So chain rule states that you can differentiate the composite function by differentiating outside of the function first and then differentiate the function inside. So this is chain rule. So let's start off with the first example. So let's say we have a composite function f(g(x) equal to 5x plus 3 to the power of 4. So when we differentiate this function, so what we get is, let's say we want to differentiate 5x plus 3 to the power of 4. So first, the function inside is function g. So we keep the function inside. So we differentiate the function outside, which is x to the power of 4. So function f is x to the power of 4. So what we get is 4, and we keep the inside, which is gx, and minus 1 multiply with the function, the derivative of the function inside, which is 5. So the answer is 25x plus 3 to the power of 3. So let's try another example to illustrate this. So let's say we want to differentiate x cubed minus 5x to the power of 5. So what we do is we differentiate the function outside first, which is x to the power of 5. So 5, and we keep the inside function, and minus 1 multiply with the derivative of the function inside, which is 3x squared minus 5. Let's try one more example. Let's say we want to differentiate sine 3x. So we know that the function outside is sine and the function inside is 3x. So what we do is we differentiate the function outside first. So derivative of sine is cosine. So we keep the function inside 3x, and we differentiate the function g, we get 3. So the answer is 3 cosine 3x. So let's try some more example. Let's say we want to differentiate tangent x squared. So we always differentiate the function outside first. So differentiation of tangent is secant square, and we keep the function inside, and we differentiate the function inside, we get 2x. So the answer is 2x secant square x square. Let's try more examples so that you have a better understanding of chain rule. So let's say we want to differentiate 1 over x squared plus 3 to the power of 5. So the first thing we want to do is we want to bring the denominator to numerator, so that become x squared plus 3 to the power of negative 5. So we do the same thing, we differentiate the function outside first. So negative 5 x squared plus 3, so minus 1 is minus 6, multiply with derivative of the function inside, which is 2x. So you will get the answer as negative 10x over x squared plus 3 to the power of 6. So let's try another example. Let's say we want to differentiate square root of x squared minus 7, let's say. So the first thing we do is we rewrite it to become x squared minus 7 to the power of half. So we differentiate the function outside. So half x squared minus 7, negative half. then we differentiate the function inside, which is 2x. So you will get the answer as x over x squared minus 7 to the power of half. Let's say we have another questions. We want to differentiate sine tangent x squared or x cubed. So let's say we want to differentiate this. What we do is we differentiate the function outside first, so become cos tangent x cubed, we keep the inside, then we differentiate the function inside. So we differentiate the function inside, we will get, so when you differentiate tangent x cubed, you will get secant square, you keep the function inside, and then you differentiate the function inside of tangent, which is 3x squared. So I hope you can see some pattern. So this is the answer. Let's say we want to differentiate this, for example, sine 5 tangent cos x squared. Let's say we want to differentiate this. So the first thing we do is we rewrite the function as sine tangent cos x squared to the power of 5. So we differentiate the function outside first. So 5 sine tangent cos x squared, and we know that 5 the power need to minus 1, so it becomes 4, and then you differentiate what is inside. So sine you will become cos, and you keep the inside, which is tangent cos x squared. Then you differentiate the function inside of sine, which is tangent cos x squared. So tangent, when you differentiate it, you become secant square cos x squared. And you differentiate, when you differentiate tangent cos x squared, you differentiate the function inside, which is cos x squared, you will get negative sine x squared multiplied with 2x. So this is the answer. Let's try one more example. Let's say now we have tangent, let's say now we have differentiation of x to the power of 4 multiplied with 2x plus 6 to the power of 3. So if you remember that if you have a product of two functions, you can use product rule for differentiation. So if you want to recall how you can perform product rule, you can check out my other video on the playlist. So basically is function f multiplied with function g, derivative of function f multiplied with function g plus derivative of function g multiplied with function f. So what you get is, let's say this is function f, this is function g. So derivative of function f, you get 4x cubed, and you multiply g is 2x plus 6 to the power of cube, plus you differentiate function g using chain rule, you will get 2x plus 6 to the power of 2 multiplied with 2 times function f, which is x to the power of 4. So you will get the answer 4x cubed 2x plus 6 to the power of cube plus 6x4 multiplied with 2x plus 6 to the power of 2. So this is how you can actually do differentiation for this kind of function. So let's try the last example. Let's say we have quotient like this and to the power of 3. So if you want to learn about quotient rule and how to differentiate a fraction of functions like this, you can check out my other videos about differentiations for using quotient rule. So for this, let's say we want to recall. So quotient rule is basically function g multiply with derivative of function f minus function f multiply with derivative of function g over g square. So this is function, the denominator is function g and the numerator is function f. So when we differentiate using the chain rule first. So the function inside we keep. So 3, 2x minus 3, 3 plus 5x square times, we want to differentiate the function inside, then only we use quotient rule. So 3 plus 5x multiply the derivative of function f, which is 2, minus function f, and derivative of function g is 5 over square of function g. So you will get this as the outcome. So we simplify, we get 3 2x minus 3 square times 6 plus 10x minus 10x plus 15 over 3 plus 5x cubed. So this is what you will get eventually, 2x minus 3 square 21 over 3 plus 5x cubed. So 21 times 3 is 63. So this is the answer for the differentiation. So if you have learned something new and you want to learn more about other mathematics topic, you can check out my playlist and subscribe to follow more mathematics topics. Thank you.